Now, very important, we are saying that when you have been given resistance in series, make sure that if there are 10, just add the total resistance, that value shall give you the total resistance. From there, that will give you, as long as the resistors have been arranged in what? In series. Thus, we are saying that combined circuit, the total resistance is R1 plus R2 plus R3. Of course, generally, we usually refer to them as effective resistance. You find a person talking about the effective resistance, what they need to do, just identify if the resistors have been arranged in series or in parallel. From there, simply get the summation, get the total resistance that are appearing in that particular circuit. That shall give you what we refer to as well, the effective one, resistance. And we are saying that this equal if the effective resistance in series, we are saying that is equal to the sum of the individual resistances in that particular circuit. Now, there is an example you want to do just before you go to the parallel. Look at this circuit. These are 4 circuits. These are R1. R1 is actually 2 ohms. Then R2 is actually 3 ohms. Then R3 is 4.5 ohms, then R4 is actually 10.5 ohms. Then of course we have been given the total voltage here is 12V. That is the voltage across the circuit that supply. Then of course we can have V1 here, then we can have V2. I need to be very careful because this is where the questions comes. Then we can have V4 on the other side. Now, somebody says, can you calculate the total resistance in this particular circuit? Very simple. When you look at the circuit, these resistors, R1, R2, R3, R4, all of them have been arranged in series. We know very well, when you talk about series, resistors being arranged in series, what you need to do, simply add the individual resistors. Resistance shall give you the summation. That one we are going to say, for us to find the total resistance here, the total resistance here, we are going to say R total. R total shall be R1, R2, R3 plus R4. Now you see, these are 4 resistors. So all of them, as long as they're arranged in series, we are going to add them. So that now we are going to say 2 plus 3 plus 4.5, then plus 10.5. Then of course when we do the summation, this is 5, we have 5.0, we have 4.5, so you have that one to be 9, then of course plus 10.5. This one is giving us what? 20 ohms. So you are saying that the total RT, this one is actually giving us 20 ohms. 20 ohms is the total resistance. Total resistance in this particular circuit. Now, another question comes in. Can you find the total current going through this circuit? Total current. And of course, we know that total current going through all the resistance is the same. And from ohms law, we are saying that V is equals to IR. And of course, we know the voltage. The voltage is actually 12V. So that now we need current. How do you find the current? Current is going to be V divided by R, using respectively the ohms law. So that we are going to say our current shall be voltage. Voltage is 12 divided by resistance. Resistance is what? Is 20. Whatever answer you are going to get shall give us the total current going through this particular circuit here. Now we can say now this one, this is 12 divided by that. If we say we can use 4 for their 5 and for their 3, so that will be 3 over 5, which is going to give us 0.61, 0.61 ampere. 0.6 shall be the total current going through this particular circuit here. So first, we have determined the total current, the total resistance, which is at 20 ohms. Looking at the resistance, 1, 2, 3, 4, add them individually. So 2 plus 3 plus 4.5 plus 10.5, we are getting total resistance as 20 ohms. Another question comes in, can you find the total current going through the circuit? How do you find the total current? We are saying that, can we respect the Ohm's law? Ohm's law says that V is equals to IR. And of course we are saying that V is equals to IR And of course, let's add in the subject of the formula, so that we are going to say divided by I divided by R. So that now we're going to say I is going to be V divided by R. And of course, you know that V is here, the total voltage across, which is 12 voltage. So 12 volts divided by the total resistance. Total resistance is actually 20 ohms, which of course we have. And of course, dividing by by 4. 4 into 25, 4 into 12, 3. Then 3 divided by 5 is going to give us 0.6. So 0.6 amperes is actually the total current going through this particular circuit here. Another question comes in. Can you find the voltage drop across R1? Can you find the total voltage across R1? What we call the voltage drop. Voltage drop, it means, can you find the voltmeter reading across our R1? How do you find voltage? Voltage, respecting the Ohm's law, we are saying that Ohm's law says that V is equals to IR. So, if you know the current, we know the resistance, it will be very easy now from there for us to find what? To find the voltage across what? Across our R1. And of course we know that from here, once we know the current, remember we know the current going through the circuit, so we know that total current here is 0.6 amperes. And remember, this particular current is the same current going through all these particular resistors. Same current. Why? We are saying in series, the current going through, the current in the circuit is the same current going through all the resistors, as long as the resistors have been arranged in series network. So we expect that current in this particular circuit is 0.6. Now from there, we are able to find what we call the voltage drop across R1. So you can say V1, which is a voltage drop across R1. How do we find that? We are going to say I, R1. But of course we know that I is equal to 0.6 amperes. So if it is 0.6 amperes, we know that resistor 1 is 2 ohms. So we can say now this one is going to be 0.6 actually times 2. And of course this one is going to give us what? 1.2 V. 1.2 V is going to be the voltage drop against what? Across our R1. 0.6, this is the current going through the circuit, and then R1 is actually 2 ohms. So when you multiply the 2, it's going to give us 1.2 V. At the same time, we can actually find V2. V2 shall be IR2. IR2, we know the current going through the circuit. Current is actually 0.6 times the resistance, R2. R2 is what? 3 ohms. So we are going to say this one is a 3. Of course, this one is going to give us what? 1.8 V. 1.8 V shall be our voltage across at resistor 2. We can actually get V3 as well. V3 is going to be IR3. 0.6, remember, same current going through the circuit, so it's better that 0.6 shall be the same current across all the resistors. So R3 is actually 4.5. So take 0. That times 4.5, we are going to have 4.5. We can say 45 over 10, you multiply by 6 over 10. So that now this one 5, 2, 5, 9. We can have 2, 1, 2 there, 3. This is at 27. 27 divided by 10, we are going to get 2.71, 2.7 V. When you multiply that, when you multiply by 0.6, you multiply by 4.5, we are going to get 2.7 voltage. At the same time, we go to what? We go to V4. V4 is going to be IR4. From there, IR4, of course, we know that the voltage, the resistance of R4 is actually 10.5. So what we need to do, we have to take I, which is 0.6. This is 0.6, we multiply by 10.5, then we see what we are going to get. Now this one, let's multiply manually, so we have 105 times 6, this one is a 30, these are 6, then from there, we have how many decimal places? We have 2 decimal places, that is 1, then 2, so it's going to give us 6.3. 6.3. So this one is going to give us 6.3 voltage. Now you see, once you have such, you have V1, you have V2, you have V3. It will be better for you to confirm that when you add V1 you add V2, you add V3, you add V4, you are likely to get the total voltage, which is what? 12 volts. That one, it must happen. Otherwise, it means that something is wrong somewhere along the calculation. So let's try. This is a V4. This is a V4. So when we take 6.3 plus 2.7, this one is going to give us 9. And when you take 9 plus 1.8, this one is going to give us 10.8. And when you add 1.2, this one is going to give us 12. So total V, total voltage is actually V1 plus V2 plus V3 plus V4, which of course is going to give us what? 12.0 voltage. So we are saying that when you do all this, you can verify that whatever you're doing is actually very, very valid, but actually adding all the values, and those values, they can give you what we are saying here. Now you can see very clearly that given a circuit with 4 resistors, then you have not been given the current. You can find the current in the circuit. You can find the total resistance in this circuit, because the resistors have been arranged in series. So once you have the resistance in series, you can actually find the total resistance. Once you have the total resistance, using the voltage total, of course you can find the total current. Once you have the total current, you can find what we call V1, voltage drop across R1, voltage drop against across V2, voltage drop against V3, then V4. Then from there, when you add all of them, they have to give you the total voltage across where? Across the circuit. So once you have them, it will be very easy for you to calculate what is required. Then from there, you can move on. Now, our next class, we'll be looking at resistors in parallel. Then we can do at least an example. Then from there, we can move to combine. When we combine series and parallel, then from there you can be able to answer as many questions as you want. Of course, from there I'll be posting some questions of the same during the class time. Just make sure you go on Google Class, then